project, we did a Nexys Player. And, I'm Mike. This is Behrooze, Sirang. So our requirements basically was to play one song, be able to adjust the volume via the buttons, also play and pause the song, restart the song or a system reset, and be able to control or be able to display the current volume and display the play time as well on the LCD screen. And here's a block diagram of the hardware. Basically, our external memory, we had to make sure whatever song or wave audio file that we put in there, the timer and counter was set in the correct frequency for that wave file, so the interrupts were correct, so it wouldn't go too fast or too slow for the song. We also used the DAC, a digital analog converter that we purchased from Digilent, and
the speaker headphone amplifier also, the other PMOD we used. So, quick rundown of how the software works. It's interrupt driven, like our waveform generator. So we have the background routine, and then we have the foreground routine. In the background, we read from the external memory. There's also an LED visualizer, so that's what light LEDs refers to. It's based on the audio data. So after the LEDs are lit, then the audio is sent to the DAC, and then we increment the playtime with millisecond accuracy, and then we update the LCD screen, and then reset the interrupt signal. And then in the foreground, we just check if we need to update the screen, and then we check the buttons for play and pause, and then increment the volume. Okay, so as mentioned before, we use a digital analog converter, and then attached to that, the output of that was a PMOD amp. So this one takes in the analog signal, and on the other end is a standard headphone jack, so we can just plug in a computer speaker. And then the Nexys One only has 4 megabytes of flash memory, and so we couldn't store really more than one song. And then I used a utility by Digilent called MemUtil. That's how I flashed the memory in the first place, with a WAV file, like on the computer through USB. And since we're using WAV files, I parse the header to make sure that the data is valid. And I have some requirements. The WAV file needs to be one channel, since we're using one DAC, and 1 byte per sample instead of 2, because the DAC has a resolution of 12 bits, so I couldn't use 2 bytes because that would be too many bits. And other than that, it'll read in the sample rate that's set in the WAV file, so that the timer knows how frequently to send interrupts. And then we fetch a sample from memory, and then so this part is software, and then this is hardware. I didn't make that distinction, but so the software samples at the correct sample rate, and volume control is implemented as a factor of the voltage values from each sample. They're just multiplied by different values. That's how you get louder and softer sound. And then the playtime, since we're using different sample rates, the playtime needs to be calculated as a function of the sample rate to be accurate. And so to test the PMOD we were using, the amplifier, I just used a waveform generator and plugged into a speaker just to make sure I can hear different tones at different frequencies. And then to test the flash memory, I initially, I just flashed the alphabet, 26 bytes, and then read it in and output it to the LCD to make sure I was reading the memory correctly. And then afterwards, I just used raw audio data, which is just a WAV file with the header. And since I knew, I just hard-coded the sample rate because I knew what I was putting on there. And once I got that to work, then I decided to parse the WAV header so that I can use multiple sample rates. And then I tested the playtime by comparing it with the actual length of the song. And we're ready to demo.